Today we're looking at how to sketch regions. Now, sketching a region is really not too much harder than just sketching a curve. The difference is that instead of sketching something like y equals x squared, we might be sketching something like y is greater than or equal to x squared. And you could have a greater than or a less than sign here, or greater than or equal to, or less than or equal to sign. So other than just sketching the line itself, we just have to take note of these couple of points. Firstly, replace your sign, whatever you have here, with a good old equals sign, because that way you're in your comfort zone and you know how to just go ahead and sketch that curve. So for one like this, we'd just sketch y equals x squared, or x squared plus y squared equals 25, which is a circle with radius 5. But we want to use a dotted line for our sketch if we're dealing with less than or greater than signs, because our line is not actually going to be a part of the region, it's just going to be a boundary of it. Whereas we want to use a solid line for our curve if we're dealing with either of these two signs, because we've got that equal to there, and that means that the line that we sketch is actually going to be a part of the region. So sketch it, choose a dotted line or a solid line, easy. Next, you've just got to choose which side of the line you need to shade. Now, there'll be occasional tricky questions where you might even need to shade both sides of the line. Most of the time it'll be one side or the other. But you'll see, potentially in textbooks, they might say to test a point on one side of the line or the other. I'm going to be really careful here and say, let's test a point on both sides, because then you're going to be really sure, and if you've got one of those tricky questions, you're not going to be caught out. And I've written here that this always works, because it literally does. But we've got an alternate method. If you've got y being the subject, so in this case here we've got y by itself, or if you have x as the subject, in other words, you might have something like x is greater than or equal to, and then you might have some things with y on the other side, then you can use this method. You can shade just above or below the line if you've got it in the form y equals something, or to the left or the right of the line if it's got x as the subject. So we'll have a look at how to do that in a moment with an example, so that will make more sense. I've written here that that's useful if your equation is in one of those forms. Obviously you could rearrange it so it is, but we've got a choice there of methods. Something that always works, something that we can use if we want to. And lastly, we want to just check our boundary points really carefully. So that's intersections that might have come up. And mark them either with closed circles if they're included in the region, or open circles if they're not. And we've seen that already with our work on the number line. If we want to include an actual point, we can colour it in and then draw a section from there onwards. Whereas if we don't want to include a point, we leave an open circle and colour in from there onwards. And it's the same when we're sketching regions. And now for some examples. Let's start with a simple one, sketching y is greater than or equal to x squared. Now we want to start by just sketching y equals x squared, and we want to choose a solid line, not a dotted line, because we can see that the line itself is going to be part of the region. So go ahead and rough that in, and you can also label that line that you've sketched so it's really clear. Now we can use one of those two methods to decide which side of the line we might need to shade. Now you can sub in a point. I can see that a point that sits somewhere like this might be the point 0, 1. And if I sub in when x is 0, I've got 0 squared, which is 0, and y would be 1. Is 1 greater than or equal to 0? Yes, it is. So this point here passes the test of fulfilling this statement, making it true. So if this side of the line works, then I can be sure that I need to shade this whole side, and all of the other points on this side of the line are going to be treated just like this one. Now, it's sensible to just double check that something on the other side doesn't work, okay? This way, if you make a mistake here, you'll spot your mistake, or perhaps you'll get around it if it's a tricky one. If I subbed in a point like, well, let's pick a point over here, like say 1, 0, if I sub 1 in for x, I've got 1 on this side and a 0 over here, and that doesn't make it true. So clearly I don't want to shade this side of the line, and I'm finished. Now, using that other method of saying, I've got y on its own here, how can I use that? Well, if you think about what y represents on this sketch, it's basically how tall the graph is, isn't it? The y value is dictating how far up and down we are. So what we're saying is we want y to be larger than x squared. Now, large values of y, they're up here, aren't they? So that tells me that we need to shade where y is big, in other words, up top, not down below. Now, that's a decent method, but I think you can see that with some graphs that are more complicated, it could be tricky working out what is the upper and the lower side. So that fallback of testing a point is a really good one. It always works. But the more of them that you do, you might realise that you instinctively kind of can see the y value needs to be big here. So obviously we're shading above the curve, not below it. And for a quick comparison, if we were sketching this one, we would have done the exact same thing, except we would have a dotted line for our y equals x squared, and we would still have shaded the upper half, and it would look something like that. For our next example, if I was to shade x squared plus y squared equals 25, I know that that's a circle with a radius of 5, and I can see that I don't actually want the line as part of my region here, so I'm going to draw my circle with a dotted line. Okay, now it doesn't have to be perfect, it's not a plot, it's a sketch. So if your circle is a little bit dodgy, like mine is, that's completely fine. For mathematical purposes, we're okay there. So I've got our circle here, which we can label x squared plus y squared equals 25. And now we have to just work out whether we're shading inside the circle or outside. So we can test a point on either side here, and I think that's the most sensible method to choose because neither of these are on their own. So how about testing a simple point like 0, 0? 0 plus 0, is that less than 25? Absolutely it is. So I can see that I need to shade the inside of the circle. Testing a point that's outside of the circle, just to double check what I've done, how about a point like 6, 0? Well, if x is 6, I've got 36 plus nothing, and that is not less than 25. So clearly I don't want to shade outside the circle, and I'm finished. Now let's look at a trickier one. We need to shade this region, and this looks a little bit unfamiliar, even if we write it like this. But if we rearrange it and write it as y equals 1 over x, now we're thinking that that's a really familiar curve. That's a hyperbola that we know. So just a basic hyperbola, and we can see that we need a solid line to graph it. So we're going to have something like this. Now, we also need to put in the fact that this curve has asymptotes on the x and the y axis. We're going to have to think about what to do about those. Now we've got to decide where to shade. Now we've got a couple of methods we can use. We can sub in some points and see, but we need to be a bit curious about what to do about these asymptotes, because if they're not part of this graph, then they're not going to be part of these regions either. Clearly y can't equal 0 and x can't equal 0 either. So what to do? Well, if we use that method of saying, let's get y by itself, so quickly rearranging this so that we have it like this, it seems that we need large values of y that are actually greater than the curve. So we're thinking that we might need to, for this section, shade the upper side, and for this section, shade the upper side. But here I'm wondering, what do we do when we shade up to this asymptote? Do we go over it or not? So you can use a combination of methods here. This is suggesting to me I probably need the upper side and the upper side, and if I'm curious about this bit, I could sub in a point to check. Let's sub in a point like -1, 1. When x is -1, is that larger than 1 over 1? No, it's actually not. So that tells me I don't want to shade this whole section here. So I've used this method to sort of reason out what I'm expecting to happen, and I can double check it by subbing in points. I can tell I don't want to shade here, and if I want to shade here, I actually know some of these points here. This is -1, -1. So I could check a point like, say, -1/2, -1/2, see if that works. Okay, is -1/2 greater than or equal to 1 over -1/2? Well, this is -2, isn't it? And -1/2 is greater than -2. So yes, I can tell that I do need to shade in there. So that gives me an indicator. Now, am I going to keep shading? Let's double check. Are we going to shade across that asymptote? Well, let's sub in a point like, say, 1, -1. When x is 1, is that greater than 1 over -1 or equal to it? Yes, it is. So if this point is in it, then I can be pretty sure that all of this is in it. And I was thinking that over here with this arm of the hyperbola, that I'd be shading the upper half because I want large values of y that are bigger than the curve. So subbing in a point like, say, 2, 2 is a good way to check. Is 2 greater than or equal to 1 over 2? Yes, it is. So I have my suspicion there confirmed, and I've gone ahead and made my graph. Now, another method that you could use here, we could have looked at the fact that we already had the x by itself. Now, this means that we want large values of x, where x is bigger than the graph. Now, think about where large values of x are. They're off to the right, aren't they? So if we look at where our curve is, and we say we need to shade everything to the right of our curve, it turns out that's actually a pretty good method for this one, because that's what we've got. For this arm, we've shaded to the right of it, and for this arm, we've shaded to the right of it. So that method worked out well. But as I said, anytime you're unsure, use a combination of the methods. Subbing in points will always help you figure out which sections you need to shade and which sections you don't. Now, it should be noted that anywhere that the right-hand side or the left-hand side of the inequation is undefined are possible boundaries, and you need to check them every time, because both sides of the boundary might be in the region or both of them might be out. So I think this is a good example, and in fact we'll also sketch this one. Here, if I fiddle with this a little bit and say, all right, well, let's just sketch this to see what we've got, then I can take the square root of both sides and I've got this, and that gives me a bit of an idea what's going on here. And this actually is just the line y equals x, and I'm going to use a solid line. Whoops, needs to go through the origin. A solid line because I can see that my sign indicates that's the case. But now when I go to check points on either side, if I sub in a point like 0, 1, I get the statement being true, so I can see I need to shade this side. But if I sub in a point like 1, 0, I can see that the statement is also true. So I end up shading the entire plane, including the line. In other words, everything is shaded. Whereas graphing this one over here, I'm going to follow the similar working to say I need a dotted line along the line y equals x, and in fact I should have labelled that. And now I can see that when I test my points on either side, I actually want to shade the upper side and the lower side. So I effectively want everything over here and everything over here. I want in fact the whole plane except for the line. So it might be handy to actually show your shading going this way and going that way rather than going all the way across to make it really clear that the line isn't included. You could even write a sentence to say shade the entire plane except the line y equals x, so it's really clear what you've done.